Assalamu alaikum warahmatullahi wabarakatuh. This is Yad, Abdullah, and me, Izzeddin, from grade 10 at Stemabur School, and we are going to calculate the gravitational acceleration using the free fall experiment. The gravitational acceleration is equal to the change in velocity over the change in time. Here we have our tools, an interface, a picket fence, a photo gate, and a laptop with Pascal Capstone application installed. And now with the experiment with Adhan Abdullah.
First, we will connect the photo gate to the digital port number 1 in the interface. Then connect the interface with the USB port to the laptop. Then we will choose the hardware setup and choose the port number 1. Then choose picket fence. Then we will choose 3 icons. The first icon will be table. The second will be graph. In the first column, we will choose speed. The second will be time. As well in the graph, the y-axis will be speed and the x-axis will be time. And in the third icon, we will choose video analysis. The third option. That's all.
Here we have the picket fence. The distance between one end of the black strip and another end of the black strip is 5 centimeters. So the distance is fixed throughout the picket fence, but the time is variable. So this is how the photo gate is going to calculate the velocity of the picket fence through each section, and through the velocity time graph, we're going to calculate the acceleration due to gravity.
Now we will start our experiment. First, record the first trial, and our friend will drop the picket fence. Drop it. Stop, and then the second trial, record, drop, stop, the third trial, record, the fourth trial, record, drop, the fifth trial, drop it, and the last and the sixth trial, drop it, and stop.
Now we're going to do some analysis of our experiment.
So here is our experiment. We will start the experiment. Here, Pascal Capstone application collected the data. So here we can take any 2 points from this table and calculate the slope, which is the acceleration due to gravity. So we will take like this is the V1, this is T1, this is the V2, and this is T2. So this is the data we collected among the 6 trials. And we collected the V1 and the V2, the T1 and T2, then we minus the V2 from V1 and T2 minus T1 and got the acceleration by the rule, which is V2 minus V1 over T2 minus T1, which is the slope of this graph.
And now we're going to use this slide to calculate or to graph the data we collected and find the line of regression. Here's the values we collected. Data set A is for the time in seconds, the x-axis, and data set B is for the velocity in meters per second, it's for the y-axis. And now we're going to calculate. So it's going to calculate the specific calculations to draw the graph. Then we're going to click create scatter graph. Here is the graph. To calculate the line of regression, we're going to press show trend line. Now we have the line of regression is equal to 99.5% statistical significance level. Now to calculate the average of acceleration due to gravity, we're going to use this column and add these numbers divided by its number to calculate the average acceleration. Here is the final value, 9.7 meters per second squared, which is an accurate value.
Now we reached the end of our video. I hope you enjoy it. Please like, subscribe, and share the video. And thank you.